Let's begin with question number 8. Let's change it to the whiteboard and let's start. Thank you. Okay. So now they asked to solve these equations. Aha. So let's solve the first one. So one is by experience, you know what to do. On the other one, by looking at it, you have to do substitution whenever you see something weird like that. So let y equals to e to the power of x. At the start itself better, so you don't have to deal with a lot of terms. How do I know must use the substitution? Because I can see it's going to be a quadratic. If it's hard to see, the substitution helps you see it. These two things are exactly the same, but e to the power x version looks a bit harder on the eyes, but the second one immediately you can recognize the quadratic hidden in it. So that's the only thing the substitution does. It makes it more obvious. That's all. Okay, then here we want to use the classical way of doing this one. What do you say? The factor thingy. Hopefully it factorizes. Most likely it does in this kind of papers. So let's start looking at it. So from here we think about the 10, but since we got a 2y and y, so it's good to just write it down like that and test. 2y times y. Then here the 10, I just think about like 2 times 5. Then I think 10 times 2, 8. 8 and not too big. I want to get -1. So I just think about the possibilities. Switch it the other way around. Seem to be possible. The adjacent numbers 5 and 4. You multiply like diagonally. So it's multiply. You get 4y. Then you multiply that upward. You get 5y. Then the middle term that I want to achieve is -1. So -1 or y, that means this is negative. So I insert a negative here. Because when you add vertically in this column, it becomes -y here. That's the bar separating. So on the left, the two columns are multiplied. 2y squared and -10. So 3 terms match means this can be factorized. How can it be factorized? Can be factorized according to the 2 factors listed here from left to right like that. Oh, so this becomes 2y minus 5 bracket bracket. This one is left to right, y plus 2 equals to 0. And then we just continue as usual. So we say either one of the numbers or factors must be 0. Because 0 times something becomes 0. So easily we can solve for the 2 values, which is y equals to 5/2. Oh, sorry, not finished yet. Sorry. Just getting ahead of myself. Sorry, y equals to 5/2 here. Or y equals to -2. Please take note the substitution back because y was not the thing given, e to the power x. Now we need to check for plausibility or whether it's possible or not. -2, impossible here because e to the power of x is always positive for all x, for all real x. That means we need to calculate only this part further. We take a ln on that or just move it there. So x equals to ln. Base is ln 5/2. Aha, ln of 5/2 is calculatable in the calculator. Okay, just put ln like that, bracket 5/2, close bracket, press equal. That can be the answer, or you can write in decimal, means let's say 3 significant figures, 0.1916. Roughly, that's the answer for the first part. Okay, let's say we're going to do the second part now. So let's take a small screen grab and clear the screen for that. So this is 8.2. We're going to use for the 8 part 2. So let's begin on that. Okay. Let's just click that. Ta-da. Okay. So 8 part 2, let's begin. So the log thingy, one of the major things or first things to look out for is the base. So always scan the base first. See whether the base is same or not. So wherever the base is same, the log laws can apply. So the base is not same, you got to change it first or make it equitable before we can apply any log laws. Depends which law you want to apply, generally speaking. Okay, so the left one, these two bases are the same. So they have the base 5, yeah? And we know that log A, the base is same. That's why they simply write the log without writing the base, because understood to assume that the base is same. It becomes log of A over B. Okay, log A minus log B is log A over B. So it becomes log 5. Aha. So this is 8y minus 6 over y minus 5. On this side, I'm just going to do two things in a go, I guess. Log 4. To find it hard, you can think of prime bases. But here we can easily see that 4 square root of 16 is 4. That means I'm using the fact that square root of 16 is 4. That means same as telling 4 square is 16. Actually, why that came out weird. See, it's quite easy to see 4 square is 16, right? So to make the base same. Anyway, doesn't matter at all. Okay, so this side becomes 2 only, because 2 log 4 when number and base same, the 2 can come in front of the power is 1, 2 times 1, because log of any base y like that is always going to be 1. Oh, so these are the tricks lah. So what I'm trying to say is this thing equals to 2. That means if I were to write one more line just to make it look nice, minus 6 y minus 5 equals to 2. So how do we solve this equation? Let's just take an anti-log. Okay, meaning that, so 8y minus 6 over y minus 5 equals to the 5 tendang there, the power go up. You can think of it like that. Or 25, 5 squared. Okay, let's try to solve it, please, on this side. Okay, so 8y minus 6 over y minus 5, y minus 5 equals to 25. Okay, now so 8y minus 6 equals to 25 bracket y minus 5. So just going to solve this. Okay, let's go ahead, please. So 25y minus 125. Let's check my calculation sometimes, So 125 minus 6, 25y minus 8y. Okay, let's just do it quickly. Sorry, 125 minus 6, 119. 25 minus 8, 17y. So what is 119 over 17? So y equals to 119 over 17. Turns out to be, there's only one value of y here, which is y equals to 7. Thank you.